So let's get to it. The Bohr model. So the Bohr model is a representation of three subatomic particles and their locations in the atom. So there are two large parts. The first one is the nucleus, where we see all of these subatomic particles, where the gray ones are neutrons, the red ones are protons, and lastly, the blue ones are the electrons. You can summarize the Bohr model using a table where the protons are positive, the electrons are negative, and the neutrons have no charge. Or we'll just write 0. The relative mass, we use this to describe this. A proton is 1 AMU. A neutron is also 1 AMU. An electron is supposed to be really teeny tiny, which is almost 1 over 1032. So it is significantly, the location is in the nucleus. And we call this the electron cloud, orbit, shell. You'll see multiple versions of this thrown around in this class, so be comfortable with all of them. So in the Bohr model, Bohr proposed that electrons are organized in orbits, or otherwise called energy levels. And so, for example, here are two elements you should have been able to have created from the lab. The inner ring, we're going to call this energy level 1. And energy level is usually designated by an N. Energy level. And this is 1. I don't know why I wrote that as an L. And here, there are actually two rings. So here I'm notifying it in the neon, N is equal to 2. So how do we describe energy levels? Well, in orbit 1, we can actually see that helium has the max number. There's 1 and 2. And we see that's consistent in neon 2, that there's only 2. So the maximum number of electrons can be 2 and energy level number 1. In energy level 2, we see that neon has also the max number. So there's 8. Energy level number 3 is actually kind of interesting. We'll talk about this, and it can hold 18. So in the Bohr model, we can also sort electrons into two categories. One is valence electrons, which are in the highest energy level, and this is the ones we talked about in the build a table activity. Electrons can also be sorted into core electrons. So here, the core electrons in neon, there are 2 core electrons, but neon has 8 valence electrons, and in total, neon has 10 electrons. Another way we can summarize this, besides the illustrations you saw previously, is using this thing called an atomic symbol. So chemists call elements using a syntax, and this is just a format in which we've all agreed upon. This is the way we talk about the subatomic particles. So it tells us the number of subatomic particles present, protons, neutrons, electrons. And so the information that is present here is, you can notice that there's a scale, so the mass number. Down here, we have the atomic number, or otherwise known as the number of protons. Lithium is shortened to Li, and this is the element symbol. And lastly, we see that this one, it could be negative or positive, and this is the charge, which gives us a really important information about the number of protons and electrons in the atom. So typically when we're identifying things, we use the periodic table. First, we're going to talk about how we can read the symbol so we can extract the information. So here we have an example of 15 phosphorus. So up top, we have the atomic number, and this tells us how many protons. Here we have the element symbol, the name. And lastly, this is called the average atomic mass. For the purposes of this class, you're usually going to round this number. So in this case, this will be rounded to 31. So let's practice reading it and being able to fill out a table like you will be doing in your homework and your upcoming quiz. So remember that the atomic number is the number of protons. And we're going to look for that in the bottom. So the number of protons is 15. The mass number is the number on top, so it's 31. And we know that the mass number is also known as the number of protons plus the number of neutrons. So we can rearrange this equation, and so the number of neutrons is the mass number minus the atomic number. So I could write this as 31 minus 15. We get a total of 16 neutrons. Number of protons is also given by the atomic number, so we can also just write 15 again here. We notice that there is no number written in the charge right here. It would be a charge number would be right there. Since there's no number, we're going to assume that this is 0. So the charge is 0. We calculate the charge by the number of protons minus the number of electrons. So in this case, we have 15 protons minus some number is equal to 0. Well, the only number that could make this true is if the number of electrons is 15. So now we have 15 minus 15 is a charge of 0. And that charge number helps us determine how many electrons there are in an element or in an atom. Some other vocabulary that might be